Hi guys, so we're still continuing with the systems of equations conversation. None of this that we're going to talk about today is new at all. We're still, whoa, I just knocked my phone. We're still in chapter 5, but we're kind of combining all the stuff that we've talked about over the past several days with substitution and elimination. Because in the grand scheme of things, it really doesn't matter which method you choose to solve a system of equations. Obviously, if the directions say solve a system using substitution or solving a system using elimination, especially on a homework or any kind of Google form check or anything like that, I will be looking specifically for your use of whatever method it's asking for. But if it simply says solve the system or solve the system however you want, it really doesn't matter. You have, again, that freedom of choice. Today, I really just wanted to talk about, there are certain situations where substitution might be easier. There are certain situations where elimination might be easier. We're not going to do graphing. We did that already, so don't worry about that. I think I mentioned at the end of the last video that, you saw this, right? I mentioned this a little bit at the end of the last video, but today we're going to talk about that slightly more in detail. And also the thing is, you might be more comfortable with one method than another. If you prefer substitution way better than elimination, obviously, you can do substitution. Technically, you can do substitution every single time if that's what you really want to do. You could do elimination every single time if that's what you really wanted to do. But I just wanted to touch on, the certain situations where substitution might be easier versus where elimination might be easier. I think I mentioned this a little bit. If you have a coefficient of 1 or -1, mostly 1, in front of either one of your equations or in front of any one of your variables in either one of the equations, substitution might be your best bet. Or if you already have something solved for one of the variables, like y equals mx plus b or something like this, where x equals 10 minus 5y, etc., etc. If you already have something that looks like this or one of the equations that looks like this, substitution will probably be easier. Elimination, if you already have it lined up something like this, where you have the 2y and the 2y, or 2y and the -2y, where it's easier to just, that would be a situation where it would just be easier to go in and add up your equations and cancel things out and solve by elimination. If you try to solve by substitution and you end up getting fractions, substitution in general might not be the way to go. Maybe elimination would probably be easier. And there's a whole thing that you're going to see or that you might have noticed in doing some of the elimination problems in regards to multiples. So what that means is, with regards to this specific example, 6 is a multiple of 3. So that might make your life slightly easier if you do elimination. Just kind of things in general. Obviously, like I said, if you're more comfortable with a specific method and you want to use that every single time, regardless of whether or not you get fractions, go for it. And just kind of thinking out loud, I might end up putting up a poll on Google Classroom just to I'm just curious about these kinds of things. Which do you prefer, elimination, substitution? Doesn't matter. So look out for that, possibly. But here we go, in terms of the problems. So solve a system using the method of your choice. So this is one of the things that I was mentioning with regards to substitution. If it were me, I'm seeing this y right here. It looks very, very simple to solve via substitution by just solving this first equation for y. Now, you could also say, on the other hand, well, didn't you just say about multiples and -6 is a multiple of 3, so can't you just do elimination? Yes, you can. Again, there are multiple ways, solving this system using either substitution or elimination should get you the exact same thing. It really doesn't matter. But, it's up to you. It's whatever you notice. It's whatever you're more comfortable with. So I'm going to do this using substitution because I'm seeing the y right here. And yeah, I think I'm blabbering too much. So when you solve that for y, you would have to add 6x to both sides. So you get y equals 6x minus 24. And if you don't remember substitution, now that we've solved that for y, we're going to take this entire 6x minus 24, and we're going to substitute it into the other equation, the 3x minus 5y equals negative 15. We're going to replace that y with this entire 6x minus 24. And because we have that coefficient of minus 5, it's really important that we put some parentheses in there. So 3x minus 5 times 6x minus 24 equals negative 15. So then we're going to distribute that negative 5 minus 30x plus 24 times 5 is 120. Combine these two like terms. Negative 27x plus 120. Subtract 120 from both sides. So negative 27x is equal to negative 135. Divide both sides by negative 27. X is equal to 5. Wow. Okay. There we go. X is equal to 5. And then it's the same thing regardless of which method you pick. We're taking that 5 and we're going to plug it into either of the original equations for x and solve for y. The numbers are slightly smaller for the second one, so I'm going to plug it in for the second one. 3 times 5 minus 5y is equal to negative 15. So this is 15 minus 15. Negative 30, and then you divide by negative 5, y equals 6. And it is still really important that you leave your final answer as, an ordered pair. There are a lot of people, when I go through your homeworks, there are still a lot of people who aren't doing this. Even if you do all the work to get the 5 and the 6, that's fantastic, but it's just that tiny little, half point extra piece to write your final answer as an ordered pair, even if you do get the right numbers. Also, please show all your work. Most of you are already doing that. Pretty much all of you are still doing that. Or pretty much all of you have been consistently doing that, which is fantastic. Keep it up. But there are still a couple people who aren't doing it. And I've left you guys should probably know who you are. And I've left multiple comments on your assignments that you've turned in, like, where's the work? You still got to show your work because, it's just integrity, all that fun stuff. Please show your work. There is really no way of getting out of all of this work with systems, unfortunately. Okay? Okay. This, to me, is something that I would probably do, elimination for. Because this is really like, okay. The multiple thing I was talking about before. 8 is a multiple of 4. 12 is also a multiple of 3. So you still have that freedom of choice in terms of which variable you want to eliminate. I don't think either of these look simple enough to solve for x or y. If, for the second one, if I think a little bit ahead, if I try to solve this for x, we would have to divide all of these numbers by 4. If I tried to solve this for y, we would have to divide all of these numbers by 3. 4 isn't divisible by 3. 3 isn't divisible by 4. So we would have some fractions, not the most fun thing in the world. So I'm going to go with solving by elimination for this one. The nice thing is that both of these variables already have opposite signs, so that takes care of some of the problem. Let's go with x this time. I think we solved the last one for y, so let's try to eliminate x, also because the numbers are slightly smaller. Elimination. So elimination, I hope you guys are still pretty comfortable with. The goal is that the coefficients have to be the same number but opposite signs, and the way you can think about what that same number is going to be is to think about least common multiple. So the least common multiple of 4 and 8 is 8. This one already has an 8, so we're going to leave it alone. Since this is negative 8, we want to keep this positive. 4 times what is going to get us positive 8? 4 times 2. So we're going to multiply the entire equation by 2. All right? So this is 8x minus 6y is equal to negative 24. I'm going to rewrite the first one underneath it for the sake of organization. And then when you add them up vertically, the x's cancel out. So negative 6 plus 12 is 6y equals negative 24. And then we can just solve for y. So y is negative 4. And then we're just going to plug it in into either one. I'm going to, again, stick with the second one because the numbers look smaller. So this is 12. Negative 24 again, divide by 4, x is negative 6. So the ordered pair here is negative 6, negative 4. And if you decide to do substitution, you should still get the exact same numbers, even if you might get some fractions along the way. A little bit messier, but still should get the same thing. And I actually put this one in here to kind of go through like both. I wanted to show you both, all right? So example 2, we're going to kind of do both and how you would get the exact same thing using either substitution or elimination. So my gut for this is to go with elimination again because the numbers are pretty big. There's no single x's or single y's. So the first thing I would say is, okay, let's do elimination. I'm actually going to split this down the middle. We're going to do elimination on the left. So I would eliminate x again because it goes back to the multiple idea. 12 is a multiple of 2. The least common multiple of 2 and 12 is 12, like I said. So we're going to leave this alone, negative 12, which means we're going to make the second equation positive. What would you have to multiply negative 2 by to get a positive 12? Negative 6. So the numbers are going to be pretty big, but nothing we can't handle. Multiply the entire second equation by negative 6. So this is 12x plus 30y is equal to positive 114. And then the top equation stays as is. X's get eliminated. This is 27y is equal to 135. Okay, so we did something like this earlier. Y is 5. Plug it into either one. Let's go with the second one. Times 5. Okay. I think that's 6. Yep, 6. Divided by negative 2. So x is negative 3. So the answer for this problem is negative 3, 5. Now on the right side, hold on, let me show you that. Negative 3, 5. On the right side, I want to do this exact same problem using substitution and really talk about substitution and really talk about how you would solve this using substitution and how you should expect to get the exact same thing. So I'm looking at the first one this time, right? Kind of like I was saying earlier, I thought a little bit ahead about would substitution make sense? Would it get us any weird numbers? And what's interesting about all 3 coefficients here, or all 3 numbers in the first equation, is that they're all divisible by 3, which actually happens to be the coefficient for y here. So if we solved the first equation for y, that would get us something a little bit simpler, no fractions, nothing weird, and we would be able to do it using substitution. So if we go in and actually do that, you would have to add 12x to both sides first. So negative 3y is 12x plus 21. And then divide everything by negative 3. So y is negative 4x minus 7. Pretty nice. We're going to plug this in for y into the second equation. So Negative 2x minus 5 times negative 4x minus 7 is equal to negative 19. So this is negative 2x plus 20. X plus 35 is negative 19. This becomes 18x. Okay. Minus 19. What is negative 19 minus 35? It is negative 54. So divide by 18. X is equal to negative 3. Oop, can you see that? Negative 3. Which just so happens to be the exact same thing we got for x earlier. It's fine that we got x first this time, not a big deal. But if we got x is equal to negative 3, when we plug negative 3 back into either one of the originals, I'm going to go with the second one again, we should also get 5 for y. Again, it really doesn't matter which one you plug negative 3 in for. So let's see if I don't run out of room. Negative 2 times negative 3 minus 5y is negative 19. So 6 minus 6 minus 6. So this is negative 5y and then negative 25. So we do get y is equal to positive 5, and the answer is still negative 3 comma 5, no matter which way you slice it. So I think that might have helped a little bit with the pros and cons of the different methods. Substitution clearly is taking up a lot more space, but elimination a lot of the times ends up with bigger numbers. So it's whichever you would rather deal with. All right. This is another example of something that I think would be way easier to do substitution for. You already have this first equation solved for y. So we could just take 4x plus 22 and plug it into the second equation for y. So 5x plus 4 times 4x plus 22. This is 5x plus 16x plus 88. 21x minus 88. This will get us negative 84 and divide by 21 to get x is negative 4. Plug that into either one. I'm going to go with the first one because it's already solved for y. So y equals 4 times negative 4 plus 22. So negative 16 plus 22 is, I think, 6? Yeah, 6. Y is 6, and that's our answer. Okay. And this is definitely, like, with all the different even and odd numbers, nothing is divisible by 4 or 5 or 3 or 2 or 9, not everything at least. So this is something that I would definitely go with elimination for. And this is one of the, in my opinion, the hardest types of elimination problems because we are going to have to multiply both equations by something. The least common multiple of 4 and 9 is 36, and the least common multiple of 5 and 4 is 20. So I'm going to eliminate the y just because the 20 is smaller, which means all the other numbers are smaller. And we are going to have to make one of these negative because they're both positive. It really, truly does not matter. So since there's a lot more negatives in the first one, I think I'm going to switch these signs to make these other two positive. So we want negative 20. So 5 times what is negative 20? Negative 4. And this one we want to be positive 20. So 4 times what is positive 20? It is 5. So when we do all that, 16x minus 20y is 44. Negative 36x plus 20y is 130. The y's cancel out. This is negative 20x. Right? Wait, 16 minus 36 is negative 20. Right? I feel like I messed up somewhere. Oh, this isn't, because this is, duh. This is negative 45x, not negative 36. I was doing 9 times 4. My bad. So 16 minus 45 is negative 29x. And then 44 plus 130 is 174. So when you divide by negative 29, definitely use your calculator for all this. I am. That gets us negative 6. And then we're going to plug that in again. So let's see. These numbers for the first one are slightly smaller, so we'll go with that. Negative 4 times negative 6 is 24. And make sure you plug into the original. If you plug into like the multiplied versions, that should probably be okay too. But if you do something like I did over here, where you messed up on the multiplication, you're obviously going to get messed up x values and then messed up y values. So I would stick with the original. So 5y, this is negative 35. So this is negative 7. So we've got negative 6 comma negative 7. And that is it. So here's the gist of it. There are certain situations where substitution is easier. There are certain situations where elimination is easier. There are pros and cons to each. If you would like to use substitution no matter what, go for it. If you would like to use elimination no matter what, go for it. You should get, as long as you're using each strategy properly, it really shouldn't matter. Or it really shouldn't matter which method you use, because you should get the exact same thing no matter what. That's the gist of it. I believe that's everything. I mean, if you have any questions, you know where to find me. And I think that's everything for today. Talk to you guys soon.